I hope you're doing well, my delovelies. So, to keep you well, I will share something. Of course, said something may contain science and vitamin D. That thing your body produces when you're, I think the word is outside? Touching grace? Something like that. The latest issue of the British Medical Journal reports that vitamin D is good for you. But specifically, that vitamin D may reduce the risk of major cardiovascular events in older adults, and in a way independent of sex or size. These findings come from a study of over 20,000 adults ages 60 to 84 given oral supplementation of vitamin D over 5 years, and as part of an absolute waterfall of studies showing that vitamin D does good stuff for us, from maintaining bone health to reducing the risk of autoimmune diseases. But, what actually is vitamin D, and how does it do all that stuff and this? Vitamins are organic molecules that are essential, at least in small quantities, to the growth and functioning of an organism. They're not the only essential nutrients. Essential fatty acids and essential amino acids are both also essential organic molecules, but they're their own thing. And then there's minerals, which are like vitamins but inorganic molecules. Together, they all account for the essential nutrients that you've gotta get from your diet. And a nutrient can be a vitamin to one species and not to others. Other species can synthesize vitamin C just fine, so ascorbic acid doesn't count as a vitamin to them. But we're scrubs. We can't do that. So for us, ascorbic acid and the ascorbates are vitamins. Even if we synthesize some amount of the nutrient, if we can't make enough on our own without dietary supplementation, then it's a vitamin, baby. That's the case for vitamin D, which is synthesized in some quantity by the keratinocytes in your skin when they're exposed to UVB radiation, and that actually gets us 70 to 80% of the way there. But we can't bootstrap that last 20 to 30%, so it's not enough that you can be a good organism without getting some vitamin D in your diet. Because vitamins are defined by how we get them in our bodies, there's no unifying function of a vitamin. They're a grab bag of stuff we needed but couldn't quite make ourselves. A lot of them are crucial ingredients to making coenzymes, which are kind of like a co-pilot for an enzyme. Vitamin deficiency means you can't fulfill the coenzyme's pre-flight checklist, which means the whole commercial jet that is your body can't take off and catalyze whatever physiological reaction that enzyme's involved in. But vitamin D isn't like those other vitamins. Once metabolized by the liver, vitamin D's active forms are steroid hormones, which just goes to show that sports anti-doping agencies should never have called specifically anabolic androgenic steroids just steroids. Because even vitamin D is a freaking steroid. They're literally just signaling molecules. And very few steroids are for making you improbably good at cycling competition. So, what does scary steroid vitamin D actually do once it's in our body? Once it's activated as calcitrol, vitamin D does a few different things through what's called the vitamin D receptor. After all, it's well and good to say something's a signaling molecule, but in order for vitamin D to actually deliver that signal to a cell, the cell has to have a way of getting the message, right? That's the role of the receptor, sensing the presence of a given molecule, which in turn prompts the cell to change its behavior in response to that signal. If a cell doesn't have the appropriate receptor, that cell might as well not even know vitamin D exists. Vitamin D receptor is expressed in most tissues of the body, and different cells do different things when vitamin D binds to those cells' vitamin D receptor. In the epithelial cells of your intestine, vitamin D receptor promotes calcium absorption so that the calcium from your milk or your leafy greens actually gets into your body rather than just going through you. In osteocytes, bone cells, the vitamin D receptor regulates many aspects of bone homeostasis, including calcium and phosphate levels, and whether those cells ought to focus on building up or breaking down bone. A bunch of different organs use calcium, including your heart, And when your blood serum calcium drops low, your body will basically raid the strategic calcium reserve in your bones to keep your available serum calcium up. Does that make you more likely to fracture a bone? Yes. Does it keep your muscles functioning? Also, yes. So we can kind of understand why truly excessive vitamin D levels cause hypercalcemia, or high calcium. The signaling from vitamin D is spamming the heck out of our vitamin D receptors and encouraging us to absorb more calcium than we know what to do with. By contrast, we also understand why low vitamin D, or mutations in the vitamin D receptor, cause weak bones and rickets, as your calcium never gets properly balanced enough to build up a good strategic calcium reserve. So, all of this explains why vitamin D is shorthanded as the bone vitamin. That, D, bone, lol. But again, the vitamin D receptor is expressed in most tissues in our body, and not all of them have anything to do with calcium. For instance, vitamin D helps your endothelial cells, your blood vessel cells, counteract the products of what are called reactive oxygen species. When you hear people going on about antioxidants, this is the oxid they're usually on about. Reactive oxygen species suppress your endothelial cells' production of nitric oxide, which they really need in order to do the dilation and contraction thing that blood vessels are known for, and with diminished nitric oxide production comes hypertension, which may be familiar to you as a thing you don't want. And if you want to talk about the definite but hard to specify functions of vitamin D, basically all cells of the immune system express vitamin D receptor, and a bunch of them actually synthesize vitamin D themselves. Remember, our body gets us 70 to 80% of the vitamin D we need, so it's not ultra weird to find cells synthesizing it. Because immune cells can synthesize vitamin D and have the receptor, they not only receive signaling from whatever vitamin D is floating around in an endocrine manner, but they can also signal their immunobuddies in a paracrine manner, and even themselves in an autocrine manner, which is kind of like me making brownies and then being like, oh hey, I have brownies. But, say it with me, biology is complex. And holy heck, the immune system may be the most complex of them all. While scientists have done in vitro studies to understand in isolation how and when monocytes and B cells and T cells each synthesize vitamin D or express vitamin D receptors, it's very much a topic of ongoing basic and clinical research. That is to say, we're still trying to figure out the mechanics of vitamin D on immune cells and what that looks like for infection, immunodeficiency, and autoimmune diseases, all of which have literature connecting to vitamin D. Okay, so that's a whole lot of information about vitamins in general and vitamin D in particular, which may act most obviously in your bones, but apparently has more subtle effects all throughout your body. I've covered only a fraction of them, y'all. It's cool. But what does this have to do with the study we started with? Namely, that vitamin D supplementation reduced the risk of cardiovascular events in old people. Because the next question I want to ask when I hear that is, how did that work? And now y'all understand when I tell you that vitamin D acts on so many different systems in the human body that any or all of the ones I've described today could be implicated in this effect. Remember how I said you need calcium for your heart muscle to function? Vitamin D's role in calcium homeostasis could be at play. What about your vascular cells and their nitric oxide? Well, I assure you, happy vascular cells are important when you're trying to avoid cardiovascular events. Okay, but surely not the immune system, Sam. Well, most of these events happen due to atherosclerosis, the buildup of plaques in your blood vessels that eventually break off and block something important. And atherosclerosis is a product of a chronic inflammatory process, meaning the immune system is necessarily involved. And why is all of this relevant to old people in particular? The study in question was performed among people 60 to 84 for a couple reasons. One is that a 2014 study published in Lancet showed that calcium that vitamin D supplementation didn't significantly affect the rate of cardiovascular events in the general population. But there's one other detail that may explain why vitamin D supplementation helped older people in particular. As you age, you express less vitamin D receptor in your cells, and your skin becomes less able to synthesize vitamin D. And lo and behold, older people are more likely to have bone fractures. They're more likely to have cardiovascular events. They're more likely to die from infectious diseases like the flu. Are all of these directly and solely attributable to changes in vitamin D synthesis and signaling as we age? Hell nah. But this is how we start making sense of it and finding leads to explain what we're seeing in clinical studies like this one. So what do we take away from all this? One, as always, is that I, your science Pippa, ask you to take care of yourself, please eat a nutritious diet, get sunlight, and get your vitamin D levels checked as needed, and particularly do the same for the older people in your life. We can only get up to 80% of the D we need without some dietary source, so fortified foods, fatty fish, gummy vitamins, whatever you need, please get that D. Yeah, no, I know, I heard it too. The next is that vitamins are defined by how we need them, not by how many roles they play in the human body. Some vitamins do mission-critical but very specific things, and for a long time that was what we thought vitamin D was with bone health. But some actually do way more than we think, and in more subtle ways than we might predict by just looking at acute deficiency models like, what happens if I just stop eating vitamin D? And with vitamin D receptor being expressed in so many different cell types, we may not always understand why, but it shouldn't seem weird to us when all these studies pop up about the role of vitamin D supplementation in various diseases and seemingly unrelated systems of the human body. I know a lot of times, this supplement works on all the systems of your body feels like a scam. And that's because a lot of the time, it is a scam. But by understanding what a vitamin does inside the human body, we can identify scams and distinguish them from genuinely helpful interventions that improve our health. Biology is complex, once again, but we're ready to vitamin D deal with it.